so everybody knows we're recording and can catch us if they couldn't make it. Sweet. Well, welcome back to the cadCAD study group. Just popping out my screen. Hope everybody had a good week. And yeah, so for today, I am just gonna give a quick recap of where we have gotten to at this point, week 3 in the study group, just to continue to hopefully orient you all with how we're trying to structure this program, and just to kick everything off, and also in case there's new people in the group, which maybe 1 or 2, we'll see. But yeah, so I'm just going to share 2 slides quick from that we actually are from the kickoff. I guess I'll just share my, let's see. The window is not showing up. I'll just do the whole screen then. Study group. Okay. Can you guys see my Discord? See my screen? Here we go. One-stop shop. Is it working? No? Oh, I think if you just have to click on it in the Discord. If you just click on it, you should be able to. Okay, so I think it's set up right. All right, so yeah, I just wanted to show these 2 slides from the kickoff meeting, just so we can get an idea of where we are in the overall course of the program. So this was one slide outlining the study group structure, and we just planned, so for weeks 1 through 3, we were planning for a crash course on cadCAD and some of the new concepts. Tyler has done that very well the last couple weeks, walking us through points, dimensions, spaces, all that fun stuff. And so now we are more on to the peer learning part, and defining our own learning goals as individuals in the study group, basically coming up with topics that we want to spend the time on, making progress during the week and getting feedback and working with peers and mentors on Tuesdays. So from last week, it seemed like most people were gravitating towards modeling a system as their first learning goal, which I think makes a lot of sense with cadCAD. But obviously, you could work on something else if you aren't interested in modeling. But I guess, yeah, cadCAD is a modeling simulations tool, so this makes sense. And yeah, so defining learning goals is kind of where we're at right now. And I know to wrap up last session, some people were sending those system ideas into Discord. Tyler has a few that he's going to talk about today. I had one that I was working on also this past week, and I can show off as well. And yeah, so we're kind of in that phase of defining the learning goals. And if you don't have one yet, that's okay. If you do have one, we would love to hear about it today. And basically, yeah, for the next few weeks, we're just going to be hacking away at these learning goals, trying to make progress on modeling these systems. This is maybe a first time modeling systems for many of us. For me, I've only really done it once or twice very long ago. And also a simple system, so I'm just picking this all up again. Some people might be more experienced that are about to learn from each other. And then just to recap also about what these learning goals could be about, I guess I've already kind of covered this, but we also want to try and emphasize again that we're hoping that this study group is both contributing to people's opportunity to learn cadCAD, but also in some ways giving back to the cadCAD Commons or the cadCAD community, so that people who come after us are able to learn from our learning journeys and maybe even use the demo models that we have or any documentation that we come up with through this process so that they can onboard themselves to cadCAD too. So this might not be totally clear like what this looks like yet as we're just starting out, but maybe keep that in mind, like how people could find this helpful if they were to come across your work in the future, or if you're building something that could be published to the public repo or documentation that could be uploaded to the wiki or something. And yeah, so that is the update, and then or the recap. And then I just wanted to quick also do a walkthrough of, well, are there any questions on those last two slides? Maybe not. Cool. All right, and then I just wanted to give another walkthrough real quick. Oh, I heard something. Yep, yeah, go for it. Yeah, sorry, I wasn't sure who that was, but if you have a question, feel free to jump in. Okay, maybe not. Yep. Ooh. Okay, it's not really working for me. Could be my internet though. Sorry, Kojak. I'm not able to hear. I don't know. Is anyone else having issues?
I'm not a coder, so I'm comfortable. I mean, I will be comfortable. I've done it before in of defining it in the math specs. Okay.
Yeah, you can do that, but I don't think that the math. I mean, okay, how do I put this? At some point, I don't think the math alone is going to be sufficient for describing the flow of information through your system. If you're trying to convert from math directly to code, what I would suggest is logically breaking out the specific information flowing through your system, and the different blocks that are interacting with that information. I would put that into a block diagram. Once you have it in a block diagram, it's not perfectly, but it's almost a one-to-one representation of the code. Right? At least that's how we're trying to develop cadCAD, so that it can be as close to a block diagram as possible.
Yeah, the math specs and the block up to the block diagram, I probably have it already.
Which is great. I think that this is a process that I think most people are going to struggle with. Yeah, that's great. If you've got your block diagrams, then I would say you're even ahead of where I am on some of my models. But I think once everyone has converted a model to block diagrams, I feel like that is going to be the best sort of jumping off point when it comes to, okay, now I know how to reason about my model. Let's go ahead and put this into code form. And having that visual representation in block form, I think, block diagram form, I think is going to be the most beneficial for most people. But the real process here that I think we're trying to exercise for everyone today is, how do you take a system that you've observed or identified in the world that you're interested in learning about? How do you take that and put it into a block diagram? Right? And how you do that depends on certain criteria for the goals that you have for your model. So you need to know exactly what it is you're modeling and why you're modeling it before you can start putting it into a block diagram. I mean, that's not entirely true. You could just take it and start putting it into block diagram form. But block diagram forms can be very abstract, or they can be very, 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 very granular. The appropriate level for your block diagram should probably start at the very abstract high level and only add complexity as needed. And the reason for that is because when you're modeling, you don't want to take every real world counterpart, every mechanism, every facet, every disturbance that could exist in the world, and factor those into your model. One, because you're never truly going to be able to have that perfect representation in code form. But two, a lot of that stuff just introduces potential for you to misinterpret or produce erroneous data. So you only want to model the exact parts of your system that you absolutely need to in order to answer your questions or meet your objectives. So what I would like out of today, what I think would be most useful, at least for me, would be to hear how people are about their models. You've got a complex system that you want to model, but you have to start somewhere. Rather than trying to model it at the most complex levels right away, how do we break that down into some very simple abstractions and start mapping those abstractions to a high-level diagram, and then add complexity to that block diagram as we go?
Mm-hmm.
So it sounds like, Kojak, you're killing it already. If you've already got the math in your block diagram, you might be well ahead of everyone else, I suspect.
No, no, it's, like in the sense, it's a very simplified and probably a first iteration, a very crude version, which I'd like to discuss with somebody out here.
Yeah.
I mean,
that's exactly what today calls for. So
yeah,
that'd
I
be
think
awesome.
that's exactly what the plan is for today. and like Tyler was saying, I think the process you're describing is what we're planning to go through or figure out how to go through over the next few weeks with the systems that we've all selected. And yeah, so I think that's exactly it, and actually a great segue into the one-stop shop. I mostly wanted to just plug this because I don't know how many people have been using it, but I have a feeling that it will be helpful over the next few weeks, and so I want to encourage people to use it. And I just wanted to show off two main spots that I think would be the most helpful. And so first of all, yeah, this is the one-stop shop. It's the home base for everything related to the program. I've been saving a bunch of, oh yeah, screen share, you got it. Okay. It should be coming through. Cool. All right. Everything I just said, plus this is the one-stop shop. And I've been personally throwing in resources that we come across each week. You can definitely do the same if you'd like. I took some notes last week. Feel free to also do the same. And yeah, for maybe actually even starting before this, like if you haven't used Notion, it's really simple. The link that we've been sharing is just brings you directly to this page. You might have to log in or create an account, but then all you have to do is click this edit button up here, and then hit continue, and then you can edit whatever you want. So first thing I wanted to say was just to encourage you to use this space how you'd like in terms of like resources and notes. But the other two areas I wanted to call out were the session signups and the active participants and learning goals. So this is active participants and learning goals page. And we created this learning journey template, which is super basic and is meant to just be a little bit of structure for the system modeling that we're all working through. And it is taking a second to load, but basically just giving, really simple structure of what is your learning goal, where do you think you'll start, and next steps, what will the delivery be, and just to give you some sort of structure to work in. I personally started with my model. I'm looking at the predator-prey model. I just started mapping some of this stuff out myself and taking notes. And I would also love to show that off today at some point. So I would encourage you to use this if you want. I think it would be helpful. I see some people have already started using it, which is awesome. And yeah, just as a way to kind of structure the workflow for the learning goals. The second thing I wanted to show off is the session signups page, which I think I think it will be helpful in the next few weeks to provide a little bit of structure for these sessions. So as Joe's was just saying, he wanted to mention or discuss the model that he is working on and get some feedback from people. And so probably the format of this might get updated as we figure out what works best, but I'm thinking at least to start to have people jump in here and sign up or somehow signal that they would like to reserve time in the study groups to discuss the work that they've been doing, either with a progress update or here is time for pitching new learning goals and deliverables. So if you haven't decided on one, but you do decide on one in the next few weeks, putting your name in here, and then we will make sure that you have time in the meeting to pitch that. If you're just looking for support or feedback on the learning goal you've been working on, then entering your information in here so we can reserve time for that. And then finally, once you are completed, probably no one for the next few weeks, but signing up here for presentations to wrap up your project. So this is just like a rough structure that I would love to be able to look at and like use to create the session agendas for the next few weeks. And I started out by just throwing my name in there. And then I know for Tyler, he wanted to also discuss some models today. And then I can also put Joe's in here. I forget your Discord name, Joe's, but yeah. So I think this was basically what I wanted to show as like hopefully what we could use to structure the sessions going forward. And yeah, so I could collect names. I think might be a good place to start actually for today. So I could give a little bit of an intro on my model. Tyler can jump into some of his topics. Kojak, Joe's, we can give you some time to discuss too. But then I just wanted to, ask, does anybody else have a topic that they'd like to discuss today? We would love to like be able to fit everyone in and make sure we have time for that. Or we can, explore each of these topics in more detail if we don't have a ton of signups. So I'll stop talking and see if anybody wants to volunteer to be put on the list for today.
I would like to.
Cool. And that was, sorry.
Nico-san.
Nico-san.
Aaron, or yes.
Cool.
However you wanna call me.
All right. And
as well.
And who is that? Sorry. Deepa.
This is, you could talk just Mo.
Demo.
Oh.
Cool. And anyone else? Cool.
Probably missed what the sign up is for. Is it for today to discuss?
Yeah, for today. So
okay.
We're just, I guess we'll see how it goes. But yeah, it's for reserving time for today to discuss either pitching the topic, like the system that you want to model, or showing off progress. You can get feedback from people as to where you should start, different resources you might use, or if you just want to talk about it and see what people say, that's fine too.
Cool.
Should I throw you on?
Yeah, go ahead and throw me on.
Cool.
Why not?
Cool.
And I'll just go first if that's okay with everyone. I only need to spend a few minutes. I just want to talk about some very simplistic models to counterbalance some of the more awesome, useful stuff that everyone else is actually going to model. But I can also demonstrate sort of breaking down these very simplistic models into a block diagram, or how you might think about it, just as like a kickoff point for people so that they kind of have a starting place for how to think about this stuff.
Mm-hmm.
I'm not saying it's the best way to do it either. Like I said, I'm part of this group for the same reasons you guys are. I'm working on the new cadCAD, but the reason why I'm working on the new cadCAD is to learn how to be a better modeler. So a lot of the questions that you guys have, I'm not going to know the answers to. I'm sort of figuring it out alongside you. So
cool. Yeah. Tyler, you can definitely jump in first, and then I'm sure we'll all be interested in that. Anyone else want to throw their name on? I have a feeling this might be we might be at a limit. I don't know. It depends on how long we take on each topic, but cool. Okay, I'll freeze it there then. And I'll just keep track of that on, oh, is my screen not being shared again?
No, it's not. One thing here, I know this is like such a pain in the ass, but one thing that I've learned with Discord is that if we're going to be doing like these big, we might want to make sure that the server itself has been boosted.
Okay.
It really does help getting those extra resources when you're doing like lots of voice and lots of video.
Okay.
Which I don't even think this is a very big group, but it seems like we're having problems, so maybe that's something to consider.
I think this might have just been me totally like screwing it up. But I'll see if we can make that happen for next week. Okay. Well, sorry for screwing that up. I don't know what people saw or didn't see, I guess, but this is the list that we have from first session signups for today. And yeah, that works. Okay, so we can just jump right into it. Tyler, I'll hand it off to you, or did someone have a question? I just heard my name. No?
Ask where I can find the link to the Notion page.
Yeah, I can repost it in the Discord channel. No problem.
Channel just now, or like a few minutes ago.
Cool. All right. So yeah, I'll stop sharing and give the stage to Tyler, so we can all learn.
Right. Share my screen. Alright. Let me know when you guys can see. If you guys can.
I got it.
You got it? Alright. So I have a list here of simple models that I just want you guys to sort of reason about and think about with me today to show that you can start with a really simplistic model and grow in complexity pretty easily. And in all of the conversations that I've had with Z and a lot of the expert modelers at Block.Science over the last couple of years, the one thing that keeps sort of coming up in conversation is that, when you are modeling something, there's this tendency to try and model it perfectly. Right? We want to have a perfect representation of all the external or exogenous stimuli that come into the system, those disturbances. We feel like every single thing needs to be accounted for, or the model itself isn't very useful. And that's actually wildly incorrect. And so something that I've had to remind myself over and over and over is you want to start with the most simplistic version of your system that you can think of that adequately describes at least the major players, mechanics, policies, actors, whatever. And then you want to grow in complexity as needed. And like I said, the way to determine, at least from my experience, the way to determine if it's appropriate to add complexity really depends on the objectives that you've outlined from the jump. Those initial goals, those questions that you want answers to. And I know that sometimes you're modeling things for more abstract reasons. Like maybe you just want to observe the behavior of certain things that you don't, or that are not well understood. In those particular cases, I think that you still have objectives, you still have goals, but maybe the boundaries aren't quite as tight. And so you can add complexity if you think that the impact that complexity is going to have on your overall model is something worth modeling, observing, right? So just to sort of bring this back to some simple models, these ones are for the most part, I think they're all systems that can be represented as open loop systems. And then with a little bit of feedback control, we're able to turn it into a closed loop. But I just want to talk through some of them with you and then show how these systems can be represented with your just standard 3-block control system diagram, like the most simplest diagram that you can. And most of these systems can be abstracted in such a way that they fit nicely into that. So I'll just sort of visually and audibly walk you through it. I'm not going to do any coding or anything, but I do have, what the fuck is this? I don't know, skip this. But I do have this right here, which is a closed loop block diagram. Very, very simple. There's nothing special here. I will sort of walk through how these different systems fit in here. We'll just talk about it, how they would fit in there. All right, so the first one is just your standard sprinkler system. For those who live in places where you have ample rainfall or snow melt or whatever, you might not have sprinklers, but here in Utah, it's a desert. We have sprinkler systems in every yard. And by default, these sprinkler systems, generally speaking, are open loop systems. And what that means is that when the water comes on, it is set ahead of time for a predetermined amount of time to run. And then it just runs for that period of time. And there's no sort of like early intervention or extending the time in which the sprinkler system runs. If you have it set to run at 5 o'clock at night for 15 minutes, guess what? It's going to do that no matter anything else. It doesn't matter if like you've been soaking the grass all day long because the kids were out playing with the hose or something like that. It doesn't matter. It just runs and there's no sort of feedback. Okay. But you could imagine taking this system and turning it into a closed loop system whereby you have a sensor that does detect something like the saturation of the soil underneath. And if there was enough water content in the soil, it might turn the sprinkler system off. Or if it was a particularly hot day and your water was evaporating a little bit earlier, I mean, maybe you should be adjusting when you do this, when you turn on the sprinklers. But assuming that it's a little warmer than usual, maybe the water isn't seeping down into the soil quite as effectively or efficiently. So maybe you have to extend that. You could add some sort of soil moisture detecting sensor into your yard, and that would provide the feedback mechanism to turn this into a closed loop system. But just really quickly, let me maybe explain this concept because I think maybe block diagrams might be new to a lot of people. This is a 3-block block diagram that is used to represent a closed loop control system. And you're going to see that a lot of my personal modeling experience and education comes from the control systems aspects of things. And that's because most of my information comes from Zargam, and that's what his background is. But anyways, an open loop system is just these two right here where you sort of have your controller in your plant that produce some sort of desired output here, but there's no ability to reinforce that signal or that process or to end it early based on some exogenous data or external data, right? We call them disturbances in control theory. So that's open because it doesn't actually have the loop. Once the loop has been completed by adding in this route right here with a sensor, we call that closed loop. And this essentially takes the output of that first process that ran, feeds it back into a sensor that says, okay, let's augment our original input signal here, or information, if you will. Let's augment that information with basically historical data from the previous time that we ran, right? Whatever the last output was, let's take that information and use it to sort of drive or control inputs into the plant going forward. So this is what we call a feedback mechanism, and you'll see them everywhere. Now, you don't have to have them, like I said, with the sprinkler system. By itself, there is no feedback. Once you add that sensor into the lawn that detects water moisture or moisture levels, then your sensor would be able to say, okay, add more water or let it run for another couple minutes or turn it off right now. We have enough, right? That's the purpose of this sensor in the feedback loop. In block diagrams, you basically have three different things. There are potential for more, but most block diagrams are going to come down to these three different elements. You have your actual blocks, you have signals or information, which is represented with directional lines or arrows, and then you have these things right here, which are called summing junctions or summing points. These are basically where two or more signals converge into a single, right? We also technically, I think there's a name for when the signal branches like this. You could call it a branch, you could call it a pickoff point, you could call it a, I don't know, there's a couple different names for these. But essentially what this is this says whatever this signal is, it's actually going to go to two different areas. You could have this arrow right here go to a completely different block or system. And I'll kind of show you that too. In fact, you might be able to say that this, it's probably best to think about this entire system as being a block itself. And the reason why it's important to think about it in that way is because when we're starting to get down into the nitty-gritty details of our models, and we're starting to sort of tease out that complexity, what you're going to find is that what you're actually describing, your model is going to be describing a system of subsystems. And those subsystems will have subsystems. But when you sort of like zoom out, what it looks like is something like this. But when you drill down into, like, for example, what the plant is, maybe you'll discover that the plant itself is a system composed itself of subsystems, right? There's this sort of like recursive nature to this. And so you can think of this system as a block that could be used in another system. And cadCAD, by the way, supports this sort of like hierarchical structure so that blocks and systems can be used interchangeably, if that makes sense. Any questions real quick? I know I'm kind of like all over the place. That's because I didn't really plan out how I was going to talk about this. I just conceptually knew I needed to.
Just to see if I understood that right, this whole little system that we have there, we could consider this as a block in like the greater scheme of things if we are going to consider it as a subsystem of a greater system, right? That's what you said?
Yep.
Okay.
Yep, so you could do something like, let me just actually show you. I'm not really good with lucid charts, so I don't know what this is. Hang on. I'm going to delete this. That right there. Make this a little bigger.
It's like going up layers of abstraction.
Yeah, exactly.
Okay.
How do I lower this? Backwards, maybe. I don't know how to do it. Yeah, but essentially, you could envision this right here as being a block that looked just like this plant, right? And it would be connected to another block or another system, right, or subsystem maybe. Itself composing another loop, right? It could also have another closed loop system like this. One way that I really like thinking about these control systems is just using like, I think the cruise control system is actually a really good one to plug in here because then you get to pass just integer values through this and you can kind of see how it works. In fact, maybe we should do that. First off, did I answer your question?
Yes, I
Okay.
understood. Thanks.
Okay. So yeah, you should be able to like go n levels deep and also abstract out. But my point in like doing this was that I want everyone to get familiar with the process of breaking down systems into block diagrams. And it's always going to be easier if you don't try doing the entire model itself with all of its inherent complexities right from the jump. Start with something very simple with just a couple blocks. In fact, sometimes you don't even need to have this. If you start with like a closed system sprinklers, or a closed loop, an open loop sprinkler system, you could probably just represent that with a single thing. I don't know what you would call it. It's kind of like the controller and plant are all in one. but you just say like my process, I guess, I don't know. And then you have some information coming in, which would be your initial conditions that say run the sprinkler for 15 minutes at 5 o'clock. And then the output, of course, is that it runs the water for 15 minutes at 5 o'clock. This isn't very interesting, but once you add in the sensor here, then this block is able to be broken out into a controller and plant part, where the controller sort of conditions your signal to then feed into the plant. Let me just really quickly, I want to explain something too. These lines represent information going through your system, but it's probably better to think of your system as taking an input and trying to produce a desired output. And all of the stuff that happens in between is the machinery or the mechanisms to try and get that signal to produce this output. But if you don't have feedback mechanisms, then it's sort of like a one-shot try, shot in the dark. We're going to pass in some information, and hopefully the processes and the machinery that are internal to this system produce the desired outcome. But if you're able to add sensors in these feedback loops, suddenly it becomes a lot more easy to just sort of pass in some initial parameters or conditions, and then the system itself sort of works towards the desired outcome, if that makes sense. And I can show you, I think this will make more sense if I talk about cruise control. So cruise control is a system, if you guys aren't familiar, every car has them, at least the newer ones. They should at this point. Cruise control is just this process that lets you lock in a speed for your vehicle, and then it will maintain that speed, assuming that the external disturbances don't push it out of its lock or whatever you want to call it. The basic premise is if I'm going 50 miles per hour, 50 kilometers per hour, and I want to maintain that speed, I first hit that speed, and then I hit like this lock, this speed lock button, this cruise control button, and then it just maintains that speed going forward until I pull out of it by either accelerating or decelerating. Okay? But in a closed or in an open loop system where we don't have this feedback mechanism, the cruise control really is just as simple as my foot is pushing against the pedal up until I reach the desired speed, and then I do not move my foot. If I want to maintain 50 kilometers, 50 miles per hour, whatever it is, then I have to keep my foot pushing that pedal in at the exact same place. Like I have to push it in so far and hold it there. If I let up on that pedal or if I push it in further, my speed is going to fluctuate. Okay? Now, that's fine. That works until the road conditions change. If I start going up a hill or start going down a hill, even if I haven't moved my foot, the car is going to start behaving differently. It's going to start accelerating or decelerating. So the closed loop system allows us to have a sensor where it automatically adjusts for those conditions. Now, the car in the modern car with cruise control systems, this happens for you, but you could simulate this same thing, cruise control, with your foot. I could say, okay, well, I'm starting to notice that the hill that I'm approaching is slowing the car down, so I need to push the pedal further in, right? But in order to maintain my speed. But that would just be me acting as the sensor here. But if we were to look at sort of like the information as it flows through here, you could see that like maybe your output here is how would I say this? Okay, so maybe the input here is how far in you're pushing the pedal. Okay, and then the output here is what your desired speed or what your current speed is once you've pushed the pedal in so far. Okay, so you've pushed the pedal in, you've hit some sort of speed here. That speed gets fed back into a sensor which says, am I going faster or slower than what my desired speed was? Now, if the sensor says you're going faster, it takes that information and feeds it back into the process of pushing the pedal in. And it says you can actually relax and pull back on the pedal a little bit because you're going too fast. Now that information gets fed through this system right here, and your speed should slow. But conversely, if the speed that came out the back of your plant was slower than what your desired speed was, the sensor would say, okay, you need to add speed. You need to push the pedal in further. Does that make sense? I'm not doing a very good job of explaining that, but that is a system that makes sense to me.
Yeah, that's good.
I think that makes sense.
Okay. All right. And when you start thinking about like just the algebra, and this is something that we can talk about later. I don't want to do it on this call, but the algebra really is like right here at this pickoff point when the signal comes out, you're actually dealing with in a cruise control system, you'd probably be dealing with some sort of integer, right? And that integer comes right here into the sensor, and really what that integer represents is your delta. How far off was my outputted signal to my desired signal? Was it was it too low or too high? And then this system as a whole is constantly trying to narrow you in, trying to focus you in on whatever your desired output is, right? Okay, a soda machine, I'm just going to really quickly, I've already dominated this call a little bit too much, but soda machine, same sort of thing. It's a open loop system wherein if you put the cup up against the lever and just leave it there, the soda machine's just going to fill it. There's no sort of like control mechanism or sensors that say, hey, your cup is full, stop filling. As long as the cup is pushing up against that lever, it's going to do its one job, and it's going to keep doing it indefinitely. If you add the sensor, in most cases, there is a sensor that provides information to your controller. The controller could be like your arm moving the cup towards or away from that lever, right? But the sensor is basically your eyes. You're looking at the soda fill in this cup, and as soon as it starts approaching the top of the cup, you tell your arm, pull back on the lever or on the cup, right, and release the pressure on that lever so that the soda stops coming out of the machine, right, because your cup's getting full. Automatic car wash, same sort of thing. This is a process in most cases, is an open loop system where you sort of just drive into this building. At least this is how it works where I live. You drive into a building, you're on a little track, right, that grabs one of the wheels, and it just moves you along at a fixed rate. Now, there's nothing in this building that says your car's particularly dirty, and the 30 seconds I just spent scrubbing whatever was not enough. I need to keep you in here longer. So you could imagine maybe developing some sort of automatic car wash, and maybe they have them, I don't know, that are a little bit more sophisticated than put them on a 3-minute ride through this tunnel, right? It would actually know the really dirty cars need a little extra love, and maybe cars that were already pretty clean can just go through the normal fixed time. Yeah, the rock, paper, scissors example is one that I used in the past. I can go over that some other time. Another one that I thought of the other day was this game every kid plays called Hot and Cold, where somebody takes something from somebody else and hides it. And then the person's like, where's my stuff? And you're like, I don't know. And they're like, I don't have time for this. I got to go to work. Right? And then just as they're about to leave the building and they're pissed off, you say something like colder. And now you've just jumped into this game where it is a system in which the feedback is you telling them, are they hotter or colder? And then, they're constantly listening to your feedback and adjusting their movement through a 3D space or through a physical environment to find the thing that you took. Right? This is something that kids do all the time. Yeah. So what I would like to see on this call is maybe some other people who have identified more simplistic versions of some of their models that they're interested in, and how they might take that and apply it to a very basic block diagram like this. It doesn't have to be even this complex. I think just a single block diagram would still be enough for a lot of people. But hopefully this kind of made sense as to how I'm thinking about these control systems. I tend to think of them just very high level. Is it open or closed system, closed loop? And then I start thinking about like, okay, well, what is the sensor in this particular thing? What is the controller in this particular thing? And that helps me sort of like reason about it. And then what I'm able to do at that point, like in the cruise control example, I would be able to sort of map it out to this system and then add complexity where, you know, maybe the sensor is not based on just my my speedometer. Maybe it's more intelligent too. Like maybe it can detect, you know, changes in the material that you're actually driving on, right? A smooth surface probably affects your speed differently than, you know, a dirt road or a gravel road. So maybe you have a number of different sensors that could all impact your overall system, but you start with just a very basic idea of your system, I guess. Does that make sense? Is there anything about what I've talked about that didn't make sense?
No, I liked it. It
feels probably pretty fifth grade, but that's where I'm starting at. So hopefully this is useful for someone without being sort of, you know, pandering or coming off as patronizing. This is literally where I have to start off. I can't jump into the really complex diagrams right from the start. I have a hard time doing that.
I have a quick question. So I'm curious, you know, once we have our block diagrams, the translation to the, I'm not sure what the right term is, but the kind of policy, state update, and then ending state diagrams, like, how do you think about representing that like temporal component as you like translate into that form?
Okay, so I think what you're talking about is another diagram that I've seen, especially the Block.Science people use, where you've got like columns and it sort of shows. Yeah, okay. So first off, you don't need those in order to sort of start modeling this. I think the block diagram is kind of the meat and potatoes for most of the work that you're going to do. Having said that, I think that other diagram, there's a reason why the Block.Science guys use it. But I also know that the way that it was used in the past was really, I think it catered to how cadCAD was developed before. And I don't know if the new reference implementation will fit cleanly with that. I suspect that it will. But because I haven't had a chance to talk to Z about that process, I can't really tell you what best practices are going to be or if there's any gotchas. I think like the nomenclature changes a little bit, right? So we don't have partial state update blocks anymore. I
found it helpful. I found it helpful to take my block diagrams like you have on your screen and then just like quickly sketch them into the other form, let's say, just because then it's like, okay, these are the sets of functions that I need to write.
That's fair.
Yeah.
That's fair. Yeah, I don't have any ideas on like best practices, but what I can do is I can like put this, like I'll make a note of this. I'll talk to Barlin, I'll talk to Danilo, I'll talk to Z and see like what their process is for taking block diagrams are and converting it to that other diagram. And then I'll do it from within the context of the reference implementation because I think that might introduce some nuance that is worth making mention of. And I would just rather you guys know about that ahead of time since the reference implementation really is going to be the version of cadCAD that we sort of push everyone to use going forward.
Got it. Just so that making sure that I'm following the distinction here. It's like there's cadCAD version, I don't know, 0. Whatever we're at right now, and then you're referring to like version 1, which is like to be released. Is that right?
Yeah. Within the next like month or so. I don't actually know. See if I can find. Somebody just posted. I don't know who it was.
Differential specification.
Yeah.
So that's what we're talking about. Is that what you're mentioning as well?
Do I just need to search for differential?
No, I don't think it was. I don't think it was called that. Where is it? Was it even in this channel? Oh yeah. ZC star. Posted it, yeah. 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 This is it, right?
Yep.
Yeah, so I gotta think that this is still applicable. I mean, you're still gonna have to define your functions. The only difference is like with partial state update blocks, you sort of had this JSON-like object where you defined all of your blocks or your partial state update blocks, and they were just like part of this single, I don't even know what you call it, the single data structure. Right? You would actually write the code somewhere else, but you just like put them all together in this single thing. Obviously, that API is going to look very different when you create blocks in the new reference implementation. You will actually add your logic for that block at the time that you define your block, and then it's about how do you string up your blocks together. And there's some API stuff there that's still a little murky for me because we haven't got to that point yet. We're still trying to make sure that our foundational concepts are going to grow with some of the more complex modeling needs. But you have to start at those building blocks. So yeah, let me talk to Z because I'm interested in this too. I actually use these quite a bit with Lithy, and this was helpful. This was very helpful. And in fact, I actually know some modelers that skip block diagrams for whatever reason and just do it in the differential.
Yeah, I have a question. Oh, sorry.
I would just have one quick thing to add. I've I mean, just like used a few different system modeling or system diagramming tools, and I feel like for me they just help explain something about a system from a different perspective, and it could be just totally personal preference too, which one makes the most sense to you, and whether it's something that has been used before, or maybe you just like have your own weird twist on block diagrams or something. But like there's almost a different language for all of these different diagrams, and they probably just whatever one is most helpful for you in understanding the system that you're looking into. Is probably best to use, but getting experience with all of them is obviously positive. So
yeah, so the way that I think about it is that a lot of these diagrams, and these are not the only other ones. I've seen some people model with the more traditional stock flow diagrams. I think that what we're really talking about is different types of diagrams to describe our system, and every single diagram type is going to have its pros and cons. It's going to highlight different aspects of your system. So it absolutely would benefit everyone to sort of familiarize yourself with these different methods for diagramming your system, because sometimes you're going to hit a system where it is sufficient to maybe just have a simple block diagram, and you can sort of like intuit everything that you need. You can see all of the connections and the relationships, and there's not really a lot that is sort of nebulous or undefined or not well understood. But for systems, especially systems where you're maybe not super familiar with it and you're modeling something that's new territory, I think that it would probably be beneficial to try representing it in multiple different diagramming types or forms, because that's going to shed light on things that one diagram might not have. Might not be able to shed light on that, if that makes sense.
Yeah,
Cool.
I think that makes sense. I had a quick question on this particular template. I mean, do you have a template that's floating around anywhere that could go up into like a repo as like a starting point?
For this one that I have up on the screen right now?
Yeah.
Yeah, because I think quite a few of them look like this, because the Ethereum cadCAD model specification also has like, the sidebars and all of that.
Yeah, so I don't have one offhand.
No. Can I ask, I mean, is there any, at least a single repo in which you can show how GDS gets converted to cadCAD?
Say that again.
Do you have at least one repo? I mean, one repo where you can show how GDS has been converted to cadCAD.
when you say GDS, you're specifically talking the math spec. Like
Not necessarily.
how do you take the math and convert it to? Okay, so
No,
if you're asking
not
how do you
necessarily.
take something like this, or a block diagram, or math, whatever, and actually convert it to cadCAD in Python code? Is that what you're wondering?
Yeah, what I'm saying is that, okay, I understand the concept. In fact, like I've actually posted a link of a crude, block diagram plus some some very basic math specs. So I mean, I'd like to know now, what do I do now from here? What for the thing? So in that context, is there? I mean, do you have at least one implementation in which you using cadCAD 1.0, your current version, in which you can
No.
show us the conversion from do you have
No.
at least one?
No. Not on the reference not on the reference implementation. There's lots and lots of examples for legacy. For the reference implementation, we have not done anything like that because the API is still being developed. So we have some of these core concepts that we know that the reference implementation needs to implement, and we've started prototyping and experimenting with what the API would look like for implementing those concepts. But the reference implementation as a whole is not to a state where we could start building some of this supplemental documentation that sort of describes the whole process of A to Z. Here's how you're going to use the reference implementation. It's not mature enough yet for that documentation because we would end up rewriting it a million times.
So how do we proceed now?
Well, okay, so that's a question that is different for everyone depending on where they are. If you're ready to start modeling something, then I would suggest, okay, this actually brings up an important point that Z had mentioned to me on a conversation that I had with him recently. You do not need to use cadCAD to model very simplistic models. And considering that I'm sitting here telling everyone that I think the best approach for modeling complex systems is to start with simplistic versions of those complex systems. And if you're dealing with a simplistic version, you're still dealing with a more simple system. And in that particular case, cadCAD, even legacy, is probably too heavy of a tool to start doing some initial modeling. But if you understand the concepts of what's represented in your block diagram, and you could start defining your own classes in whatever language you wanted and start presenting some of these concepts yourself with just purely custom code. What cadCAD offers really is the sugar for making and building out very complex systems of subsystems of subsystems that need to be run many, many, many times. It provides the sugar for making that process just easier, right? But like the systems that I've identified here, cadCAD does not need to be used for any of these. And what Z was suggesting that I do in my own personal experience would be to model these things just using Python, just develop my own classes, my own data classes, and then writing the code to perform the logic, and then you have these functions that take some input and spit out some output. You wire them together manually in Python, and you just use that for your first couple iterations of the model. Once your system starts getting more and more complex, at some point you're going to find that modeling and executing the model is becoming sort of laborious. And at that point, it might make sense to take cadCAD and start developing your model in that framework.
The problem which I face is that I'm not a coder. I can.
cadCAD won't fix that for you, though. Like you're still going to have to know how to do some programming. And the programming that you would have to do in a cadCAD model is going to be the same kind of, like the same level of programming you would have to do if you were to skip cadCAD and just model it in basic Python. I'm sorry. I know I cut you off there. I didn't mean to. Do you kind of understand what I'm getting at? Okay.
Yeah, I completely understand what you're getting at, but all that I'm asking is that, I mean, I'd like to develop this particular model to a level at which I can seek help in coding. I mean, I don't think I'll ever do the coding myself.
Yeah. I mean,
No, the thing is that, people like us exist in the world. Everybody is not a coder.
Mm-hmm. Oh, no, I know. And I'm not trying to like say that you've got to pick up all these skills to be able to do something meaningful. I think that it really depends on what you're trying to do. If you're intending on building the models themselves and not just running models, there's going to be some programming involved. But sort of my perspective as I'm working on the reference implementation, my primary objective personally is to make the UX easy for people who are not programmers, to make the UX easy for people who are not math people, right? Or who are maybe not engineers. And so I'm thinking about this problem a lot, but in your particular case, I think you've got a model well defined. You just don't know what to do with it yet. Am I understanding that correctly?
Absolutely. Of the thing, because I mean, I can, keep refining the model, but the point is like exactly what you said. I'd rather do something, a very small bit of it, and run it before I really start, getting into.
It's hard for me to suggest where to go next because really I think like both of the paths that I see ahead of you, if you actually want to build the model and run it yourself, I see two paths. One, you keep it super simplistic, you skip cadCAD and you just model it in Python or some other programming language. I highly recommend Python, especially given that you don't have a lot of programming experience, but it could be in anything. The other path is that you try and do it in cadCAD, which you can do, just like other frameworks or libraries that sort of do the hand-holding for you in some places. I feel like that can be an artificial crutch that can end up getting you in trouble. I also think that cadCAD would demand a lot from you that your simplistic model just doesn't need right now. So I think that's part of the reason why Zargham suggested, for me personally, that the easiest thing to do early on is to start with your very simplistic model in just vanilla Python code, where you build some sort of data structure that represents your information, and then you write some functions that do transformations of that information, and then you put them together. There's not really any wrong way to do it per se, but you keep it all in basic Python.
Maybe it would be a good idea if this would be something that we can all model as a community, in the sense that for us to all learn how to actually do it.
I know.
It's beneficial for both parties, considering that he's not much of a coder, and by the fact that he has an actual model that can be implemented, it could be good practice for us to go over that.
Yeah, I'm all for that.
Can you just repeat? I mean, I couldn't hear what you said.
Yeah, so as I understood it, he was suggesting, that maybe one of these very simplistic models, actually writing it in vanilla Python, be an exercise that us as a study group do together. But if we do that, I'm probably going to hand the reins to somebody else, because I don't want this to feel like I'm the one sort of driving this thing.
But you mean like doing that right now?
I think
one of those little models?
I think over the next few weeks, or I mean, it's not like too complex of a model, so it's technically done being diagrammed. So you probably could start with it next week. But yeah, I mean, Tyler, you don't have to do that if that's not your plan.
No. It's not that I don't want to, Peter. It's just that like I don't want this. We're going 3 weeks in. We're going to be going 4 weeks in, and I don't. The more that I talk, the more that people think that I have answers. And we are literally. I gotta stress to you guys. I literally don't know what the fuck I'm talking about at this point forward, because I'm learning it with you. So if you're starting to get into territory where I can't help.
Yeah.
Right. And I don't want that to be something that impedes you guys.
Yeah, and maybe I can jump into my model then now and just show off a little bit of what I've been working on too. But like to that very point, like I am also not a coder. Like I don't have any development skills. I've used SQL, but and like a tiny bit of Python. But my plan for this program was basically to get some experience programming, and if cadCAD isn't quite ready yet, then and if it's even probably too powerful for the models that I was working with anyways, then doing that in Python is the next best experience. And I think whether you end up modeling it in cadCAD or in Python as, you know, your own structure or whatever, like you're going to learn a lot. You're going to learn a lot about how to think about systems, how they work, how they would be implemented in code, and then like all of those learnings will be transferred in some way to more complex systems and more powerful models when you start using cadCAD. So that's, I guess, how I'm like personally thinking about it. And so I will definitely end up writing code for my model, whether that's, well, it probably won't be next week, but in the next few weeks. And yeah, Nikos, if that's something you're interested in too, then I would definitely encourage you to do that.
So yeah, I just want to say one thing real quick.
Yep.
I think that cadCAD legacy and even cadCAD reference implementation, when it's like done, I do think I agree with Zargam. I think that it's too heavy for most people who are starting those very first models. Right? We can't just jump in and model the big thing right from the go. So we have to start small. And I think the cadCAD might be, for a lot of people, too heavy when you're starting out really small. Having said that, the reason why I was really pushing for people to learn the concepts of the reference implementation is because we have code in there right now that you sort of use to build out very simplistic models that is only barely a touch above doing it yourself. So, like, I'm sharing my screen again. For those who haven't seen this, this is just my rock, paper, scissors model. I built this in a Jupyter notebook. I import my blocks, spaces, dimensions, and points. These are my cornerstones, my foundations of, like, my model, right? I could have developed these just as, like, I don't know, a static data structure. I didn't need to build in quite such sophisticated classes of these things, but I could have built simpler versions of them. But the point is the same. I define my dimensions, my spaces, I add some functions to my block, I create a block, and then I run it, and I get output. Now, I have to manually do my looping, right? So this isn't a very useful system perhaps, but I'm able to get data out of it. And I feel like this is, at least for me, this is probably how I will be building out all of my models. It's technically the reference implementation, but it comes without all of the syntactic sugar on top for running simulations and experiments and Monte Carlo runs and parameter sweeps. It gets rid of all of that. I'm constructing my model in as simple of units as I possibly can. Blocks, spaces, dimensions, points. And the code is not that complex. I mean, granted, I developed it and I've been looking at it for months, so take that with a grain. But I view this as only barely harder than doing it myself in pure Python without the use of a library. So for those who are looking for a little bit of structure, I highly recommend this path.
Yeah.
You can take the reference implementation. We have this data or these classes in a branch that you can check out, and then you can construct models, very simplistic models, in the exact same way that I did. You just have to wire them up manually. Mm-hmm. And what do I mean by wire them up? If you want to run a simulation, you need to figure out how to do that. I create a block, but it doesn't just run by itself. I actually have to, map that block to data, and then it produces new data. And if I had more than one block, then I would have to be responsible for saying, okay, run this first block, take the output of that block and feed it into the next block, if that makes sense.
Tyler, does the reference implementation run on an API, or is it, like, as I understand the old version, something you actually run on your own machine?
Yeah, okay, so when I say API, I'm not talking about web HTTP APIs. This is something I gotta keep in mind. I know everyone's getting confused. When I say API, what I'm talking about is when in the cadCAD library, when it comes time to create a dimension, what is the code syntax that you have to use to create a dimension? I built this class called dimension, which takes a data type as its first parameter and a name, a string, as its second. If I change what parameters are here or how the internals of this dimension class work, I am changing the API. Actually, technically, if I change the internal.
Basically, okay, so it's an internal, so there's nothing actually, it's not like we're now moving to a subscription model of...
No. It's not anything like that. I'm just saying the way that you use cadCAD, the functions you have to call, what those functions are even called, what parameters get passed in what order, what data is necessary, what data do you get out of it. All of that is part of the API. It's your interface with the library or with the framework.
Okay.
And that's what has not been set in stone yet. And so that's why I'm kind of like teetering on this line where I want you guys to understand these concepts because these are GDS concepts. But I also understand that by using this library, if you define a dimension like this today, I guarantee a month from now dimensions are going to change. You're not going to create dimensions like this. But maybe that doesn't matter because at least you can get started today exploring the concepts. Yes, the parameters change.
If one is fairly sort of fluent in the old version, when is the right time to seriously jump into the new version?
I mean, it depends. I hate that that's the answer, but there's so many variables there. What were you using the old one for? If you were only using the old one to run fairly simple models, then you're probably looking at like maybe a couple weeks to a month before you can do it.
Let's say digital twin of Uniswap using external signals for arbitrage strategies.
Yep, I would at least wait until the 1.0 release. I don't know when that's going to be though. I mean, I don't know. I have no idea. So when I originally took on this project of doing the rewrite, that's what it started as, was like a rewrite because I wanted to fix the API and the UX around Legacy because Legacy was really clunky and every minor version broke API and made it so that it was just really hard to develop consistent models and upgrade cadCAD versions without fearing that everything you had developed in the past was going to break. On top of that, there was way too much boilerplate, and there was a lot of unnecessary just stuff that you had to do to get things working. So my intention with the rewrite was to fix all of that, but internally it would still be the same cadCAD. It would function the same way. But as we started exploring this, Zargam requested rethinking the way that we do it with some of the things that we've learned over the last 3 years with Legacy. And so we went back to the drawing board and we've come up with a completely different architecture for the software. But because it's completely new, I can't give you a good ETA. And any ETA I gave you today would be like not reliable at all. I thought the original timeline of like 2 weeks was more than enough time. Because I've seen people create very similar things to what we have in like a week. So I was telling people.
So if you're already in a complicated modeling setup in the old version, are you sort of suggesting that this is going to be a distraction following the course, or are you saying, well, keep following? Because I think some of the stuff you're saying is like there's different audiences here, and I don't pretend to be a super coder, but I've been on some of the previous courses, and I guess you learn a lot with open source. So I'm wondering, does it make sense to are we following a sort of introductory approach to cadCAD generalized, or are we looking into cadCAD 1.0 specifically at some stage?
Kind of both. So I'm trying to explain the concepts of GDS, which will fit neatly with the reference implementation when it comes out.
Okay.
But because it's not fully developed right now, I think that there's kind of a, if people are looking to develop really big complex things today, they need to use legacy. There's just really not any other alternative. But as far as sort of like the general principles versus 1.0 in particular, or the reference implementation in particular, I want both. Because I think the future of cadCAD is reference implementation. In fact, I know it is. So I want people to be familiar with it, but I also understand that we're still early. And so I'm trying not to get people to do too much with it, if that makes
sense. Okay. Makes sense. Thank you.
Okay. Cool. Yeah, I'm really struggling with this one because, you know, it's like I told Heater when he originally approached me about, like, would cadCAD reference implementation be ready for the study group? I think I told him yes. And the reason why is because we had some pretty ambitious timelines, but I felt like even if those slipped a little bit, we would be okay. But as it turns out, this new architecture is forcing us to rethink a lot. And every time we make a change, I go back and revisit it from the perspective of this needs to be easy and fun to use for people who don't know math and for people who are not programmers or who are not engineers. It needs to be as simple for those people as it can be, while also being flexible enough for the power user. And so it's taken longer than originally anticipated.
Yeah. Yeah, and I mean, I like, me personally, I wouldn't have been into like deep into coding and building complex models with cadCAD 1.0 even if it was ready right now. So that's part of like why I think, why I still have plans and can see like a path forward for the ideas that I had for the study group and the learning goal that I picked. Like, there's still plenty of room for me to go learning just modeling and simulations practices before getting deep into cadCAD 1.0. So that's personally like why I'm planning to continue doing this. But then, like Henrik, yeah, as you said, if your goal is to just be able to translate your already quite complex model that you've completed, you know, majority of the modeling and simulation steps for, but translate that into 1.0, it might not be the perfect time. So yeah, I guess that's.
Well, most of 1.0, to be fair, most of what we've talked about with 1.0 is really just the GDS concepts, which can be applied to the modeling work that you do in any modeling framework, whether you're doing it without a framework and just doing it in vanilla Python, like I suggested for very simple ones, or if you were using Legacy or RadCAD or something like that. Mm-hmm. You could take these concepts and apply them. So the concepts themselves are foundational. I think they're important for everyone to learn. It's just that when you start getting into the territory of, all right, let's actually write some code, that's where I'm like, it kind of depends on what you as a modeler intend to do. If you're just exploring very simple stuff for now, just write it in Python. If you have something that's, you know, really complex and you're ready to start modeling it now, then let's go with Legacy or RadCAD or something like that.
Mm-hmm. Cool.
Got it. I'm on RadCAD.
Yeah, I know a lot of people like RadCAD, and the thing is, like, you know, even RadCAD, I have a meeting planned this week with Ben, who wrote RadCAD, to sort of tell him where we're going with the reference implementation, and I suspect that he will be incorporating a lot of the changes that we're making to keep RadCAD closely aligned. So, but we also have a Julia version that's like the reference implementation, but it's going to be performant. That's also right around the corner as well. So.
Thanks.
All right. So,
yeah.
I want to say something there.
Yeah, jump in.
Yeah, sure. So, well, I'm very new to all of these concepts and even this kind of way of thinking, like this book, like thinking in systems, right?
Yep.
Uh, like everything in the end, we can take it down to a system. Well, I don't know if anything, but I see a lot of it all the time now that I have been exposed to all of these concepts. But
Mhm.
something that I feel is that so far there is too much abstraction in the in the information, and I particularly need to get it down, right? Like get it down to earth. And of course, that is my job. That is something that I have to do. And the only way to do that is like get your hands dirty. So
Yep.
like what are like thinking about the model more than in my head, like actually trying to put it into a diagram, but then actually doing the code, which I still I would have to like install everything, I guess. So my question was, I guess we're already getting to that point where we are going to start doing that together. But then,
Hmm.
which is what concerned me, or more than concerned, about how we are going to take this approach. Are we going to be studying these simpler pre models, or shall we jump into whatever ideas we have? And so, if we can jump into our ideas, how do
Yeah.
we organize to do that? Because, for example, like now we have like 30 minutes left today. I don't think we could like search all of the ideas that everyone had.
Yeah.
So are we gonna have like other sessions, or and well, of course, it also depends on our individual wants, right, and things that we do. But any other kind of mentorship, any other kind of moments where we gather to actually do these kind of things or look for mentorship? I don't know.
Hmm.
How are we
Yeah.
organizing that?
Yeah. Yeah.
How's the
So
future?
so that's I think like the goal of the study group is to be like we are that for what you're trying to do. And as for
Okay.
like the path forward, I mean maybe this is where I can jump into the model that I was looking at, but or yeah, my modeling idea. But I mean that's something that I'm also like sort of learning on the go. And at this point, I
Yeah.
picked a really simple model. I started with the predator prey system, and well,
Hmm.
yeah, simple if you assume a lot of things away, but it can be simple.
Yeah.
And
So
so
my
that's the
other
model.
concern is that,
Yeah.
like, well, individually, like, in regards to the model that I'm trying to ice or develop,
Mhm.
uh, I don't know whether the thing that I'm figuring or what I just put is well thought, or if it's right, like even in the way it's presented, right, with the arrows and everything and symbols.
Mhm.
So like, I was wondering if maybe I could show what I've got so far and see if I am doing it right
Yeah.
or if there's anything wrong. And then, like, what would be the shortest path of learning with resources that I can take in order to be more, let's say, proficient or knowledgeable into thinking in systems in
Mhm.
this way?
Yeah. So I mean I personally have come across I mean I've kind of just dove down that rabbit hole on my own over the last week and before that a bit too, but just like coming across different resources, systems thinking videos, like systems design videos on YouTube and other resources from the token engineering community. And I'm
Mm.
planning on just kind of creating my own like self-learning, self-study curriculum. And I personally would love to share that, like those resources and what I learn with you and get feedback from you on what you're learning and hear. So I guess the way that I see it is there's not like a direct curriculum yet
Yeah.
for what we're trying to do, which is why like we're all here confused. And that's why I think there could be value in a study group because what you just said in like how you want what you want to get out of this program or your goals with systems modeling and thinking is
Mhm.
very similar to myself and probably other people in the group too, at least a few. And so, yeah, I think that creating the learning environment is the goal here. While there isn't a set curriculum for how to get this information directly, um, we're just going to be able to experience it and go through it together. So it's definitely not like the most efficient path from A to B, and beginner to expert, but like, yeah, so that's kind of how I see it. And yeah. So,
all right. Yeah, I think that sounds great. And
cool.
Sorry.
Yeah, was somebody else?
I just wanted to recommend a movie called Thinking in Systems.
Oh, sorry, it's quite, I think I heard you say recommending the Thinking in Systems.
Correct.
Yeah. Cool. Yeah, I've come across those too.
All right.
Yeah. I think it's a really good YouTube channel called Thinking in Systems. I can post the link.
The actual book.
Yeah,
Oh, the book.
There's a book by Diana
Meadows.
Okay.
It's a really good book that introduces all of these concepts in terms of shopping flows and.
I just posted a link to it in the chat.
Awesome. Cool.
Great
yeah.
book.
Thinking in Systems book.
Yeah, that's a fundamental book.
Cool. Yeah, I think I've checked out some of that, but okay. So then I guess as for the last 20 minutes, I think Nico-san, you obviously you pointed this out too. We probably won't have time to get through everyone's topics that I collected at the beginning of the meeting, but I think that could be, well, so I guess I'll start and just go through mine like really quick, and to give you guys an idea of like how I'm thinking about taking this like the next few steps in this the next few steps in the learning process, and then because I feel like that's just like the only way that I can really explain how it might look for over the next few weeks for you if you continue joining. So okay, so I just shared my screen. I think you should be able to see it. And let me double check. Yep. Okay. So this is the sign up sheet. Okay, well, we got through Tyler. And now, I'll jump in. So I had been saving my learning journey document in the one-stop shop. And yeah, basically I started with this predator-prey model. I'm planning to, my learning goal as I outlined it would be to map out the system for the predator-prey model so that it's ready for implementation in cadCAD 1.0. This is basically my understanding of the furthest that you can get with cadCAD 1.0, and seems to align with what Tyler was mentioning, where in terms of like how far the reference implementation is for usability. And I just want to be able to take this system and either write it in code like Tyler had done for the rock, paper, scissors, or even in words and block diagrams and stock and flow model and et cetera. So just be able to like understand it in a way that could be implemented in cadCAD 1.0. That's, I guess, my goal. As for the learning process, so let's see, learning 1.0 concepts as a reference in my head. So we've kind of done that already. Picking a simple system that would be interesting to learn. I've gone with predator-prey. Try and express that in 1.0 concepts so that it would be ready to write in code. Realize I can't express that in cadCAD 1.0 concepts yet, but use other system mapping tools to understand the system better until I can. So this is, I guess, where I'm planning to go the next few weeks. So I started just by like thinking of questions like, why am I experimenting with this model? What do I want to learn from going through this process? And I guess I'm picking this model because it's simple if you assume things away, as I said, and it's been done before. So there's different resources out there that I can actually look at and hopefully learn from already. so it's not like totally new. And then some of my other goals are to get experience with basic systems mapping tools, so like the entity relationship diagrams, causal loop diagrams, stock and flow diagrams, block diagrams. So these are all things that I think we've already talked about in the last, today really. But yeah, just getting experience with those. And like you said, Nico-san, I don't know if I'm doing it right, but I'm planning on trying and then communicating to you guys what I've tried and see if anybody in here who has more experience than me has feedback and learn that way. Eventually, I will translate this into math specification and then try to actually express it in cadCAD 1.0 concepts with the dimensions, points, spaces that Tyler's mentioned the last few weeks, and possibly start translating that into code using what's available in the reference implementation. If that doesn't work, or if it's not, I don't know, if it's not possible or whatever, I'll probably just go with the simple, or probably won't be that simple, but I'll just go with the basic implementation in Python without using cadCAD, like Tyler was mentioning, if that's, the best path forward at that point, but I'll get there. So that's pretty much what I've outlined. It's really not much in detail yet about about my learning journey. I think I also had I started super simple on Lucidchart with the system. I outlined some questions that I have about the system. What's the max population that the ecosystem will hold? What is the long-term equilibrium of the population? So I guess these are the goals of the model that I would build. I also highlighted some assumptions. Predators eat the prey to survive and die if they don't. The prey reproduce naturally. I'm not introducing any other animals yet, and age is not a factor yet, so they wouldn't die from being old. So this is basically, that's all I have to share. And I plan to come next week, I guess, with more detail on different, probably one or two more diagrams in more detail on what the system, how the system looks. And I would probably show that to everyone and hopefully get some feedback. But that's kind of where I've gotten to just in the last week with that topic. So maybe that helped give you an idea of my plan and how you might, pick a system on your own and work through some of those steps to get experience modeling too. But sorry, my voice is kind of getting lost, but that's all I've got. I saw Tyler unmuted. Do you have any comment?
Yeah, I was gonna say just my opinions that I've expressed on this call and these calls are almost all coming from Z. I'm not saying it's the right way, but I just want you guys to know that I'm not just pulling, my butt or out of a hat. This is random. A lot of the suggestions for how to approach problems are takeaways from having conversations with Z, who, if you guys don't already know, Zargam started Block.Science to do complex modeling. He has done a metric ton of it, and he's got a team of really smart modelers and engineers and scientists and mathematicians that do modeling with him. And these are best practices or suggestions coming from him and his many, many years of experience doing this. So I know it seems kind of weird for me on a cadCAD study group to be oh, maybe you guys should model without cadCAD. But this was actually a suggestion from him where he said if the model is not complex enough, cadCAD might feel really heavy, and modeling shouldn't be something where you have to do a bunch of extra stuff just to get something running. It's faster and easier to get your hands dirty with concepts if you're doing it more hands-on without the added of the frameworks for very simple models. And then once you grow to a certain size, that's where cadCAD's use case is. And I think for a lot of people, that's going to be eye-opening, because I think I know I did. I thought cadCAD was just this, you use it for everything. And you can, But I just want people to understand that it does come with some heaviness, and it might make sense in the exploratory stages to just do some stuff in Python. And I apologize that we don't have a lot of good onboarding resources, like collectively, put into a single resource where you just read this document, you go through, check off all the boxes, and now you're a modeler. That's something I'm trying to make better, but there's so much nuance to every model that people want to work on that creating a really streamlined onboarding process has been super difficult. It's just, there's a lot that you need to know, right? It's not just knowing the token economics of the system. You're also going to need to know programming. You're going to need to know control systems or systems theory, at least a little bit. And so there's just a little bit of a learning curve there.
Yeah, totally. And I mean, you won't be, even if cadCAD 1.0 were ready today and you didn't know how to do any systems modeling, you probably wouldn't be able to use it. So this is like the steps towards using cadCAD do include very simple modeling to start and eventually building yourself up in complexity towards that stage. So that's how I see it at least.
Yeah. I think during this next week, I'll put together a list of this in chat in the text channel. I'll put together a list, like a master list of the resources that I have, aggregated myself over all these conversations for the last 2 or 3 years. I'll put them all together in a Git repo, a Markdown file, so everyone has access to them, but it just won't include the sort of guidelines or the rails to let people know, okay, here's what you should actually focus on, and this is just for supplemental education or supplemental information. But here's the core that you need to have, because I haven't had time to go through and just review everything, distill it all down into the must-knows. But I'll do that, and then I'll work on those models that I talked about today. I can go ahead and start putting those together in basic Python without cadCAD, and then I can just spend 10 minutes next week talking about how I put them together in Python, just as a frame of reference for everyone else.
Mm-hmm.
And hopefully what you guys start to see is over the next couple of weeks, I want you guys doing this alongside me, but hopefully you'll see like those models are going to grow complexity, and at some point it's going to be a pain in the ass to do it all in just vanilla Python. So then at some point I'll introduce cadCAD, whether it's legacy or the reference implementation, that has yet to be determined.
Mm-hmm.
But I will introduce it at some point in the future.
Cool. Awesome. And I do apologize for not getting to the list of topics. I think we did get a little sidetracked, but in a good way. I think it was worth the conversation. I mean, we only have 10 minutes left. I suppose we could probably just have any last questions and then wrap up. But yeah, so I think Tyler mentioned his plan for next week. My plan is also to just go a little bit further into the models that I had, the predator-prey model that I had been looking at. And I hope that's, makes sense for you guys. Does anybody have any last comments about it? If there aren't, then we could, hear from someone else. But yeah, go ahead.
Yeah, thank you. I want to find out, like, is it possible to have or to model metrics using cadCAD, like the one you'll be working on, that is predictor tree? Is it possible to have maybe performance something, whatever? So I just need insight into that.
Sorry, I'm not sure I got the whole question. The audio was cutting out a bit, but
okay. Can you have a system in cadCAD to model what metrics of a system should be? Let's say kind of performance evaluation of a system. Is it possible in cadCAD? Let's say I have a system. Let's say a school system or a university system obviously I must have deliverables. So can I model metrics for success rate with cadCAD?
Metrics for what? Sorry.
Success rates.
Success rate.
You can. In Legacy, metrics are supported. They will be in the reference implementation, but the reference implementation in its current state has not developed to that level yet. We're still doing kind of the foundational stuff. But yeah, if you do like a pip install cadCAD, you will get the Legacy version, and it does support metrics. Yeah.
Cool.
All right, thank
Does
you.
that answer your question?
Yes, thank you.
All right. Anyone else have questions? Is anyone else working on or have a model topic that they're planning to dive into further for next week? We probably don't have time think of some. And
will we be able to present? Yeah, would I be able to present next week?
Yeah. And so I again apologize about the running out of time. But that is the plan for like the coming weeks, is to just fill up the sign up sheet with folks who'd like to give show off the work they've been doing on their systems. And you are both on the sign up sheet now, so you'll be front of the list.
Good.
Cool. And in the meantime too, like if you want to throw in resources that you've found helpful as you're diving into your systems, or post screenshots and just be like, did I do this right? If someone has time to jump in and like give some feedback in the Discord, they would. I'm sure that'll happen. So
Sure.
Cool.
I'm interested in that conversation you were having with Ralph this morning. So if there's an opportunity to collaborate there, just let me know.
Awesome.
Excuse me, who's speaking at that?
It was Mike, Quiet Catalyst.
Mike. Alrighty, perfect. Send me a message. I definitely would like to talk about it.
Cool.
Perfect. Alrighty.
Sweet. That's all I have for today. Any last comments before we close out?
Thank you.
Cool.
Thank you.
Thanks for joining. Appreciate it.
Appreciate you doing
Next week.
Thank you.
Thanks, guys.
Nice.
Cool. See y'all.